Good morning, children. In the previous class, we have studied about uniform speed, non-uniform speed. What is meant by uniform speed, children? If a body covers equal distances in equal intervals of time, if a body covers equal distances in equal intervals of time, however small the time intervals may be, then we say the body is moving with uniform speed. Then non-uniform speed. What is meant by non-uniform speed? If a body covers unequal distances, 10 kilometers, 20 kilometers in second hour, again 5 kilometers in third hour, again 10 kilometers in fourth hour. 1 hour, 1 hour, 1 hour, 1 hour. If a body covers unequal distances in equal intervals of time or equal distances, that is 10 kilometers everywhere, in unequal intervals of time, then we say the body is moving with non-uniform speed. I repeat, children, if a body covers equal distances in equal intervals of time, however small the time intervals may be, then we say the body is moving with uniform speed. If a body covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, however small the time intervals may be, then we say the body is moving with non-uniform speed or variable speed. Next, average speed. Average speed. What is meant by average speed? You might have knowledge about average. What is average, children? Sum of the quantities by number of quantities. So, average speed is equal to total distance covered by the body, by total time taken. That means you are taking suppose you are going from one place to another place. Suppose you are going from your native place to Tirumala. How the bus will go? It will go with different speeds. Anybody ask you at what speed you have travelled in your bus, you cannot say particular speed. In that situation, what will we do? We'll go for the average speed. Average speed of your vehicle will decide as the speed of your vehicle. Then you will say average, on an average it has went on with the speed of 50 km per hour. For that purposes, we'll use the average speed. I repeat, children, if you are going from one place to another place, in a bus or in a train or in a vehicle, it will be going on changing its speed. If you want to identify the particular speed of your vehicle, then what will we do? We'll go for the average of a speed of a vehicle and we say it has gone with that speed. In that situations, we'll use average speed, that is total distance by total time taken. Then instantaneous speed. What is instantaneous speed? Instantaneous means the terminology itself says it is instant. You might have heard about instant coffee, instant idli, that means immediately at that moment. So what is instantaneous speed? It is nothing but speed of a vehicle at the given time, at a given instant of time is nothing but instantaneous speed. Okay, children, here is a question that what is the device used to measure the speed of a vehicle? How can you measure the speed of a vehicle? The device used is speedometer. You might have observed in your bike there is a speedometer indicating the reading at what speed you are going. Whereas, what is the device used to measure distance covered by a body? How much distance you have covered is given by odometer. Odometer is a device which calculates the distance covered. It will be seen in the vehicle in a rectangular box. That's all, children, regarding speed. Once again, I will repeat, children. Uniform speed covers equal distances in equal intervals of time, however small the time intervals may be, is called uniform speed. Non-uniform speed, if it covers unequal distances in equal intervals of time or equal distances in unequal intervals of time, however small the time intervals may be, then we say the body is moving with non-uniform speed or variable speed. Average speed is nothing but total distance to total time. Instantaneous speed is speed of a vehicle at a given time. Speedometer is a device used to measure the speed, whereas odometer is a device used to measure the distance. Here if you observe children, distance by time ratio is constant. In this case, if you observe, distance by time, if you take in every situation distance by time, for example, here 10 by 1, that is 10 km per hour. 10 by 1, 10 km per hour. 10 distance, time is 1 hour, 10 km per hour. Everywhere it remains constant. If you see non-uniform speed, 10 kilometers per an hour in the first 1 hour. Second 1 hour is 20 kilometers per hour, 20 kilometer per hour. Third situation is 5 kilometers by 1 hour, 5 kilometer per hour. That is, here the distance by time is not constant, is not equal to constant. I repeat children, if distance by time remains to be constant, it is called uniform speed. If distance by time is not equal to constant, it is non-uniform speed. With this, the types of speed has completed. Now we will go into the different topic called velocity. Before going into the topic, let us know the terminology of the types of quantities. What are the different types of quantities we have? You know, according to magnitude and direction. What is magnitude, children? If I say length of a pencil is this many centimeters, that is magnitude. Direction, particular direction. Based upon magnitude and direction, physical quantities are divided into two types, children. What are the two types? Scalar quantity, vector quantity. I repeat, depending upon magnitude and direction, physical quantities are divided into two types: scalar quantity, vector quantity. What is scalar quantity? For example, I want to measure the length of this marker pen. If I take a scale, if I measure the length of a marker pen from this side to this side, it will give you particular length. Same scale if I use, if I measure the length from here to here, the length will be the same. It will not change, it will not depend upon the particular direction. Such quantities are called as scalar quantities, which has only magnitude but no particular direction. Only magnitude. If they have no direction, then such quantities are scalar quantities. What is a vector quantity? Suppose you invite me to your house to come. Just 2 kilometers from the school, you just come, you will reach my house. Can I come to your home? No, I cannot come because I should know the particular direction. You should suggest me in this direction. If you come, you will reach my home. Then only I can come to your home. That means in such situations, directions are very important. That means a physical quantity which has both magnitude as well as direction is called vector quantity. Both magnitude and direction. For example, in the previous class you read about distance and displacement. Distance does not require any particular direction. It is a path covered by a body. But if you mention the distance with the direction, we call it as displacement. Displacement is a vector quantity. That means if you say like 4 kilometers towards east, it is displacement. If you say simply 4 kilometers, then it comes under distance. Next, speed is a scalar quantity. Speed is nothing but distance by time, and hence it is a scalar quantity. Whereas, with a particular direction, 4 kilometers towards east, I am traveling in 1 hour. Then it comes a new terminology nothing but velocity. So what is velocity? It is nothing but displacement by time. Displacement by time. I repeat children, distance is a scalar quantity. Speed is equal to distance by time. Velocity is a vector quantity. Displacement is a vector quantity. Velocity is equal to displacement by time. This is our today's topic, children. What is velocity? Now you might have got an idea like speed and velocity. What is the difference? Only the difference is speed does not have direction. Velocity have direction. So what is velocity? Velocity is nothing but displacement by time. Displacement by time. Displacement by time. Children, I told you in the previous class, by time is nothing but rate of. So rate of displacement covered. Rate of displacement covered is nothing but velocity. Displacement covered is nothing but velocity. For example, if I say I have travelled 4 kilometers towards east in 1 hour. That means what happens? Velocity is equal to 4 kilometers per 1 hour towards east. I repeat children, if I say displacement 4 kilometers towards east in 1 hour, then velocity is 4 kilometers per hour towards east. Like this you can calculate velocity. Come on children, what are the units of velocity? Velocity is equal to displacement is nothing but a length. So displacement units is meter per second. Time is measured in seconds. So meter per second. So this is nothing but MKS unit of velocity. Then what is SI unit of velocity? SI and MKS system one and the same. SI unit also speed meter per second only. Then what? CGS unit of velocity? Meter per centimeter. Length is measured in centimeter per second. CGS unit is centimeter per second. Then what is bigger unit of this? Bigger unit is kilometer per hour. Kilometer per hour. From this what do you understand? The units of speed and velocity are same. The units of speed and velocity are same. Is it clear children? Now we are going to learn about types of velocity. Types of velocity easily you'll understand as you had already the knowledge of types of speed. What are the types of speed? The same only you have types of velocity. So you just start repeating with me children. Types of velocity. The first type is uniform velocity. What is uniform velocity? Here, must and should. In uniform speed, it may be a curved path, it may be a straight like this, whatever it may be. In the previous class, I have explained by drawing a straight line. Today, I have drawn a curved path and explained uniform speed. That only equal distances, no particular direction. But in uniform velocity, definitely the body should go in a particular direction because in velocity direction is important. So the body moves in a particular direction. If it covers equal displacement, when it goes in a particular direction, we say it's as displacement. So equal displacement in equal intervals of time, then we say the body is moving with uniform velocity. But in the previous class I told you, not only the whole journey, not only in 1 hour, in every fraction of second it should complete equal displacements. That is the meaning nothing but however small the time intervals may be. However small the time intervals may be. I repeat children, if a body covers equal displacements in equal intervals of time, however small the time intervals may be, in equal intervals of time, however small the time intervals may be, then the body is said to be traveling with uniform speed. Next, non-uniform speed. I repeat, sorry children, it's uniform velocity, non-uniform velocity. What is uniform velocity? If a body covers equal displacements in equal intervals of time, however small the time intervals may be, then the body is moving with uniform velocity. What is non-uniform velocity? If a body covers, here also particular direction you should have children. If a body covers unequal displacements, if a body covers unequal displacements, 10 here, 5 kilometers, everywhere 1 hour, 1 hour, 1 hour, 1 hour. If a body covers unequal displacements in equal intervals of time or equal displacements, 10 kilometers, everywhere 10 kilometers, 10, here also 10, but the time is 1 hour, here 2 hours, here 1 hour, here half an hour, like this. That is, time interval is changing here, displacements are same. In this case, then we say the body is moving with non-uniform velocity or variable velocity. I repeat children, if a body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time, however small the time intervals may be, then we say the body is moving with non-uniform velocity. Once again you take down this, take down my note. If a body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time, however small the time intervals may be, then the body is said to be moving with non-uniform velocity or variable velocity. Next one is average velocity. What is average velocity? It is nothing but total displacement covered by a body, total displacement by, average speed is nothing but total distance by total time. Similarly, average velocity is nothing but total displacement covered by a body by total time. Next one is instantaneous velocity. What is instantaneous velocity? It is nothing but the velocity of a body at a particular instant of time. The velocity of a body at a particular instant of time. At a particular or at a given instant of time is nothing but instantaneous velocity. I repeat children. Uniform velocity is nothing but if a body covers equal displacements in equal intervals of time, however small the time intervals may be, then uniform velocity. Here, when you take displacement by, here the displacement covered is equal in equal intervals of time. When you take non-uniform velocity, variable velocity, here the body covers unequal displacements in equal intervals of time or equal displacements in unequal intervals of time, however small the time intervals may be, then we say the body is moving with non-uniform velocity or variable velocity. Average velocity is nothing but total displacement by total time. Instantaneous velocity is nothing but velocity of a body at particular instant of time. Now a question for you children, when the speed and the velocity of a body will become equal? When it is possible when the speed and velocity of a body is equal? When the body moves in a straight line. When the body moves in a straight line, speed will be equal to velocity children, because speed is nothing but distance covered by a body by time. Velocity is nothing but displacement by time. When a body moves in a straight line, distance is equal to displacement and hence speed is equal to velocity. I hope you understood children. So we have completed the concept children. Thank you children.